say about distance formula. It is an extension off of our Pythagorean theorem lesson, where with Pythagorean theorem, we were looking at actual geometric shapes, right? We were looking at right triangles and finding either the missing leg or finding the missing hypotenuse, or using the missing leg and missing hypotenuse to complete either a perimeter or an area problem. But sometimes you're not just given an actual shape. Sometimes you are having to find the measurement when given a coordinate plane. So if I were to give you the following, and let's say that this was a 1, this is a 2, this is a 3, and we'll say this is 1, 2, 3, -1, -2, -3, and of course -1, -2, and -3. Okay, so I have my little quick grid here that I'm going to go and do. And let's say that I have point A and point B. You could tell me how far apart point A and point B are, couldn't you? If I say, what is the measurement of the line segment that would connect those together? So I want to know, what does line segment AB measure? Right now, you could do that pretty easily by just doing what? Come on, guys, think through it. I shouldn't have just one person raising their hand. If I wanted you to find out the measurement from A to B, what's a simple technique that you would just do right now? Devin? Huh? Add what? Well, 3 plus -2 is going to give me 1. So are they only 1? Is that only 1 distance? No. But that's close. You're on the right track. Jair? Okay, so you can count the number of units that it's between, right? We could count the distance or the number of units. So we could go, okay, well, this is 1 unit, 2 units, 3 units, 4, 5 units. Okay, if I were to start at one point and count the number of units straight down, it would be 5 units. So this is 5 units. And again, we can't put any other measurement besides units because it is on a coordinate graph. Okay, I could do the same exact thing again. If I make another coordinate grid, say this is 1, 2, 3, 4. This is -1, -2, -3, -4. If I have point A here and point B here, and I want to know, okay, what is the measure of line segment AB? It's the same exact process, isn't it? Just counting how many units are they apart, but now we're talking about a horizontal line. So we're going 1, 2, 3, 4, 5, 6, 7 units. Okay, so those are easy. If we know that we're dealing with points that are vertical to each other, directly vertical to each other, or if we're dealing with units that are directly horizontal to each other, we can just count and find the distance between. So here's the question to ask. If I have point A here and point B is here, can I just directly count? Is there a way for me to count any measures this way? Yes or no? No. You can only count units when they're directly vertical or directly horizontal. So what do we do in a situation like this when we're dealing with a diagonal measurement? So remember, diagonal measurements are just your hypotenuse, right? I can form a right triangle within this graph by saying, okay, well, I can count how many measurements over to form one leg and how many measurements down to form the other leg and form a right triangle. There is a formula for this. It is called the distance formula. And what the distance formula states is that distance squared is equal to, okay, this distance squared, that's the same thing as our c squared here, is equal to the measurements for our x's. So to go from one x to the other x, I would take my x2 and subtract my x1. That's going to give me a leg. And of course, like anything, we always square the leg. And then we're going to add it with the measurement that goes from y to y. So the difference between y2 minus y1, and that's another leg. Well, don't forget you have to square those legs. Remember, leg squared plus leg squared equals hypotenuse squared. This measurement right here, this d, which we're labeling as distance, that is your hypotenuse. So leg squared plus leg squared equals hypotenuse squared. But we don't want the hypotenuse to be squared. We want just the hypotenuse. So what do we always have to do at the end? Square root it. So really, if we take the square root of d squared, then that means the distance is going to be equal to the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. This is your distance formula. So to be able to find the distance between 2 points, any 2 points, you can plug them into this formula and find the difference between them. So if we were to go ahead and do that here, point A right now is at -2, +3. Point B is at +1, -2. If I plug it into my formula, I would subtract my x's. So my x values are -2 and a +1. So I'm just going to do -2 minus 1, square that, plus the difference between my y's, 3 minus -2. 3 minus -2, and then square that value as well. What is -2 minus 1? What is -2 minus 1? -3. So we get -3 squared plus, what is 3 minus -2? 5. Good. So we get 5 squared. What's -3 to the second power equal? 9, right? -3 times -3 is +9. What's 5 squared? 25. So then 9 plus 25 equals what? 9 plus 25 is 34. And then when we take the square root of 34, so again, this is when you're going to need to use your calculator in classic mode. If it's not in classic mode, you're going to click mode, scroll all the way down till you have classic, and highlight classic by hitting enter, clear out, and then it should be in classic mode where you have parentheses around it. You would do square root of 34 and you get 5.83, or just 5.8. So our distance here is 5.8 units. Okay? This is the distance formula. You are just you're subtracting your x's, square it, subtract your y's, square it, add those values together, square root. That's your distance formula. It's very, very simple. And this formula will be given to you on a reference sheet. Okay? Can I move past? No, you're still copying? Go ahead. Okay, so let's take a look at this one. We have point A, which is at 2, 3, point C, which is at 6, 6, and we want to know the measurement between A and C. Okay, so again, our distance formula states that we need to go ahead and find the difference between the x's and the difference between the y's. So I'm going to go ahead and label these using different colors, stating that this is going to be my x1, my y1. This is going to be my x2 and my y2. And within the formula, it states, okay, you have to subtract your x's. So I'm going to do 2 minus 6. Then I'll square that value and add it with the subtraction between my y's and squaring it. So my y's are 3 minus 6. Okay, and it doesn't matter the order, because if I do 2 minus 6, I'm going to get negative 4. But if I do 6 minus 2, I'm going to get positive 4. But once I square them, it doesn't matter whether it was negative or positive, it's going to wind up being positive anyway. Right? Negative 4 squared and positive 4 squared are the exact same value. So it does not matter the order that you're subtracting them, as long as you know that you are subtracting them and then squaring the value. Okay, so just as I just said, 2 minus the 6 is going to give me negative 4, and I'll square that. 3 minus the 6 is going to give me a negative 3, and I'll square that value. Okay, so negative 4 squared comes out to 16. Negative 3 squared comes out to 9. And when I add 16 and 9 together, I get 25. And then the square root of 25 is what? 5. So we get 5 units. And that's it. So again, you're finding the difference between the x's and the difference between the y's. You're then squaring those values, adding them, square root, you're done. So essentially all you're doing is finding the leg measurements, like what we did at the very beginning. We found a vertical leg and a horizontal leg. A vertical leg and a horizontal leg, and square the legs, add square root. That's all you're going to be doing. Try this one on your own. And be mindful of your negatives. Negatives are not the same thing as subtraction. So that's the number one mistake people make, is they see minus a negative and they automatically drop one of those. Don't drop a negative sign. Go ahead and do problem 2 on your own. All right, who can tell me what they got for this one? Leo? Not 15. Kelly? 13. Okay, we should have gotten 13. So again, we're just going to work this out real quickly. We have the square root where we're going to find the difference between our x's. Here's our x1. Here's our y1, our x2, and our y2. So we're just going to find the difference between them. So we're going to take negative 2 and we're going to subtract a negative 7. Then we're going to square that value. Then we're going to find the difference between our y's. So we're going to have negative 7 minus a positive 5. Okay? When we subtract negative 2 minus a negative 7, negative 2 minus a negative 7 is going to give us a positive 5, so we're going to get 5 squared. Negative 7 minus 5 is going to give us a negative 12, so we're going to have negative 12 squared. Okay, then we're going to do 5 squared, which is 25, negative 12 squared, which is 144. When we add those together, we're going to get 169, and then the square root of 169 is going to come out to 13. So this is 13 units for our distance. 13 units for the distance. Okay, let's take a look at another one. Let's go. A is at 1.9. B is at 7.1. A is at 1.9. B is at 7.1. All right, who can tell me what they got for the distance for those 2 points? Aiden? 10 units. Very good. So again, we're just going to take the difference between the values and then square those differences and then add them together and take the square root. So for here, this is going to be our x1, our y1. This is our x2 and our y2. We're going to do 1 minus 7 squared, and we're going to do 9 minus 1 squared. Okay, 1 minus the 7 is going to give us a negative 6 squared. And then 9 minus 1 is going to give us an 8 squared. When we square those values, that's going to come out to the square root of 36 plus 64. 36 plus 64 comes out to 100, and then the square root of 100 is 10. Sorry, I ran out of room writing this. So it's 10 units. 10 units for that one. Okay, let's go ahead and I'm going to put up 2 more questions for you to do on your own as well, and then we'll be done for the day. Let me go ahead and move this on. Question number 4. A is at 1.52. C is at negative 1.5, negative 1.5. And then question number 5. A is at 5/4 and negative 2/3. And B is at 3/8 and negative 1/9. Go ahead and do those ones on your own. Okay, let's go over this one. For problem number 4, who can tell me what they got? Eric? About 4.6. Yeah, if you round it to the nearest tenth, it's going to come out to roughly about 4.6. So if we take a look here, this is going to be our x1, our y1. This value here is going to be our x2 and our y2. When we set it up, notice, guys, that every time I set the problem up, I always set up my parentheses and my subtraction sign inside of my parentheses first. I set all of these little tiny tidbits up first before I start putting the numbers in, just so that I make sure I don't forget to write a subtraction sign in case of a negative, okay? So I always want to get that set up first. So here I'm going to go ahead and do 1.5 minus a negative 1.5. And then here I'll have a 2 minus a negative 1.5. I don't want to get those confused, okay? Now, 1.5 minus a negative 1.5, that's going to come out to 3. So we're going to have 3 squared. Plus 2 minus a negative 1.5, that's going to come out to a 3.5. And, of course, we're going to square that. Okay, 3 squared is going to come out to 9. And then 3.5 squared comes out to 12.25. When we combine those values together, we're going to get 21.25. And then, of course, when we take the square root, we're going to get approximately 4.6 units. It's an approximation. Okay? Now, for problem number 5, I'll go ahead. If you got roughly around 1.03 or 1.029, those would be the answers. It obviously would have to be simplified soon to like a decimal, because once you're taking the square root of that fraction, it will come out to a decimal in that classic mode. Okay? The setup for this, though, that's what I really want to focus on, is the proper setup. So we have our subtraction, addition, our parentheses, squaring values, subtractions inside. Again, we're setting it up where we've got these x1s and y1s, and we've got the x2 and the y2. Okay, so x1 is our 5 over 4 minus our x2, which is 3 over 8. Our y1 is a negative 2/3 minus our y2, which is a negative 1/8. Okay, then once we subtract 5/4 minus the 3/8, that's going to come out to 7/8. So we have 7/8 squared plus, when we do negative 2/3 minus 1/8, that's going to come out to a negative 13 over 24. And then we'll square that. Now remember, when you're squaring a fraction, you're squaring both the numerator and the denominator. So 7 over 8 squared comes out to 49 over 64. And then negative 13 over 24 squared comes out to a positive 169 over 576. Then once you add those fractions together, you're going to get 305 over 288. 305 over 288. Then once you take the square root of that, it comes out to approximately 1.03 or 1.029. Okay? All right, in our next class, we'll go ahead and do some online practice, or some cumulative practice of both Pythagorean theorem and our distance formula. Your test, you do have a test next week. It is going to be on Wednesday. Wednesday is your test next week.